Okay, good morning, everyone. I'm basically the last speaker before lunch, so I'll try and keep you awake and focused. We're going to talk about, from the food producer's perspective, what are the challenges that we face when we want to substitute. And thank you, Thomas, for the introduction. You essentially discussed the theory, which I touch upon. So, how do you identify a chemical of concern? I'm going to gloss over that since it was in great detail just described. And then identifying suitable alternatives. And then let's talk about how do you qualify the alternatives. And I'm going to spend the most of my time on this last point. We're going to give a kind of bare bones outline, and then we'll go into 2 case studies. So how do you determine you have a chemical of concern to eliminate it? 3 areas: toxicology regulations, public concern, and sometimes these are all combined together, and that public concern influences regulation. Toxicology studies come out and you say, oh, shoot, we need to get out of this chemical. So you need to determine, are there suitable alternatives? Are they available from the packaging supplier? Gee, we'd like to get out of this chemical, but there's nothing on the market right now. Are they allowed by regulations? We have polycarbonate water bottles in China. We'd like to get out of those, but you know what? Polycarbonate is what you are required to have for big 5-gallon water bottles, so it's kind of hard to get out of polycarbonate. Is it safe? What are the alternatives? Are they safe? Do they work as well as the original? This is one of those fuzzy areas. You've got alternatives, but how do they perform when you actually put that in contact with food? And then the general question is, how long does it take? Why does it take so long? Why can't you be out already? So, let's talk about those points. Is there a suitable alternative available? If yes, you have 0 development time. If no, 3 years, maybe more, maybe 10 years. I was just talking to an antioxidant supplier who said they've been working on something for almost 10 years. It takes a long time to develop something from scratch. Is the alternative allowed by regulations? If the answer is no, you need to add in a couple of years, maybe 4 years, to get approvals. EU, FDA, Mercosur, China, those are the big 4. How long does it take? It takes quite a while. So, at the food producer level, you have a new packaging material coming in with a new substance. Okay, we need to confirm regulatory status. Let's look at the COC, the DOC. Let's make sure that's aligned. We have to do a safety evaluation. So then you're talking analytical testing. We have to do a production evaluation. This is where you actually see if you can fill it on the production line. Are you going to need new equipment because it's got a different friction coefficient? Or things get gummed up if it runs too fast, so you're going to have to run slower? And then when all that is said and done, let's see what happens when you pack it and you keep it for your shelf life. Presenter earlier, Joanna from BRC, talked about 1 month for chocolate. Make sure some smelly compounds didn't get in. That's an example of a shelf life. So, safety evaluation. You need to do migration testing. You need to do extraction, injection on the instruments, 10 days minimum. It's kind of interesting because the chemical contaminants part of the testing laboratories throughout Nestlé have a less than 5-day turnaround, yet most of the migration protocols require 10-day. And when they put out an edict, everybody must have a turnaround time of 5 days. It's kind of hard when you have a 10-day incubation period. So then you need to do analysis by GC or LC, and of course you need to review the data to see what kind of peaks you have. And I just threw a simple chromatogram up there to show you that when you start talking about some of these very small peaks, it takes a while to identify, assess the hazards, et cetera, I think Gregor talked about we need to make sure we know exactly what is everything that's in here. So, and then review identification of NIAS. Once again, these small peaks, you may have to call in a toxicologist and say, hey guys, here's what we found. Are these a problem? And all of this takes time. 6 months, 9 months, maybe even a year. It depends upon how well known the base chemistry is. Are we talking about just an additive, or are we doing something completely new? Suitable alternatives. So let's talk about production evaluation. Okay, we have a new package. Supplier says it's great. Okay, we need to fill it. That means we have to go to a factory. Great. Well, when is the factory able to fill it? Usually at the end of production on a Saturday night at about 2 a.m. You know, it's these windows of opportunity aren't readily available Monday through Friday at banker's hours. So you need to schedule when you're going to fill. And this can be 3 months in advance, even if you have everybody behind you. Sometimes you can move things up, but you get an idea. It may take 6 months to get this all done and then shipped somewhere where they can do some testing. Then you need shelf life quality checks. Let's see if there are any off flavors, off odors, or other failures that happen over the 6-month shelf life, or with cans. They can be 2 years. So basically, if you put things in a summary form of the steps, you need to select, verify regulatory, verify safety, verify production, and then verify that shelf life works. 1 to 5 years. If you have no problems along the way. It's when you get problems that you start having to reset the clock. So let's talk about example number 1. Replacement of ITX photoinitiator and ink. This happened back in 2006. Photoinitiator, apparently there are 79 alternatives, according to Gregor. UV photoinitiators. So, alternatives, yes, they were known. We need to check regulatory compliance. We need to conduct a safety evaluation, find out if there's any migration or set-off migration. Let's do a production evaluation. For something that's an ink component on the outside, for production you're talking scratch resistant, line speed. Is there any problems? Not too complicated, or shall I say rather straightforward. And then the shelf life study focused on organoleptic. Do these inks migrate through and cause a problem? And this was kind of pushed through because there was a problem in Nestlé with ITX, and it was pushed through as fast as possible. It was a little bit less than a year. 1 year, 1 compound, when everything was good. Let's talk about example 2. Placement of BPA in can coatings. Just pick this one out of the air. The key difference between this example 1 and this example was that the alternatives were not widely used or known. Regulatory compliance. It was more than just a review of documentation. Some of these things had to be developed and submitted to the authorities. The alternatives were based on polyester, the acrylates, PVC, and oleo resins. The thing about it is, the epoxy coatings had been optimized, and pretty much these other resins were left drifting. They weren't used all that much. So when it came time to, we need to pack in polyester, it was found that some of the foods really weren't suited. Once you get into something acidic, it starts eating through the polyester. We need to upgrade the technology. We need to develop new materials to fill in, the performance gap. All of these previously used or alternatives, PVC or oleo resin is the old resin that was around before BPA. It apparently fell apart rather quickly, so you had very short shelf lives. You have to develop these materials, and then regulatory approval takes 2 years. One thing I wanted to say is the alternatives, they're not based on BPS or BPF because Nestlé decided very early on that was just moving into a regrettable substitution. So safety evaluation on the new materials. You have to do migration. You need to do tox assessment of NIAS. 6 months to a year, maybe even longer, because this is new technology. We are not sure what's out there. We have to evaluate a lot. We have to talk to our suppliers. We need to collaborate. And oh yeah, and we have to make sure it works. Production trials. Okay, we gotta get new cans with the new coating. We gotta fill it on the production line. While you're doing that, you can run multiple coatings at the same time, but that still makes it a little more difficult, a little more complicated. You have to track whose is which, is where, is how many how many different versions do you have. And then you have shelf life 2 years to complete. What kind of challenges do you have with that? Well, it's new technology. Okay, we had a failure, but we traced it to the fact that the guy who was putting the coating on didn't cure it properly, or he didn't put a thick enough coating on, or he put too thick on, or something. So the new technology, how do you work with this stuff? The suppliers, have had 60 years to optimize BPA so that you can fall out of a boat, hit water, and you've achieved your objective, because bisphenol A was one of those really good all-use, multi-purpose can coatings. The coatings were not guaranteed for the previous shelf life. Oh, you have a 2-year shelf life. Well, sorry, we don't know enough to guarantee that this coating is going to work, so we'll tell you 6 months. Shorter shelf life means more food waste. We got to take this slow because we want to make sure that we ensure we're providing the same quality product for the same duration, so that we don't start getting into these issues of we're shorting the world food supply. Cans were one of the nice things that were cheap to make, and they last up to 2 years. So when you have a failure of a coating and you trace it, it can be sensory. Oh, my canned milk tastes funny after a year or 9 months. The coating performance, oh, it starts to flake off or it rusts. You don't find these things out for a while. Or you have production performance. Oh, we're trying to run, and guess what? You ship the steel plate that's coated across the equator, and now all the plates stick together because that wasn't considered, because it was developed in Northern Europe and nobody bothered to think it will heat up when it's on the ship going south. To take a random example. Okay, so here are 3 pictures. These are real pictures of failed trials. We're not using these coatings. After 4 months, you have this black stuff around the edge, or the side stripe is discoloring and coming off. And if it's coming off and it's a sealed environment, it's going into the food. So then you have also this one picture all the way on the right. You see after 9 months, you start getting corrosion at the bottom. This is not a pretty picture. This is certainly not anything any food producer wants to put out on the market.
Under which conditions were these tested?
I don't have the details. I can just say these are real pictures. And then this picture was provided by a can maker as a really good example of the adhesion loss. This is a brown product, like a gravy or something, and the gray coating. They opened up the top, and there was the coating right on top of the food. I'm not sure about you guys, but if I ever opened up a can and saw that, I'd never want to buy that product or brand or anything again. And these are real problems that really occurred while we're working very hard to get rid of a chemical of concern. And when you have the failures, you lose 1+ year or more. depends when the failure is, and then you reset the clock. And this is really frustrating. If you have a harvest pack, you have compounded your problem because you can only pack in autumn. If you have a pack and you have a failure after 4 months, you have to wait until autumn, September, October again. If you have a failure of, say, evaporated milk, okay, you can go milk a cow and process some stuff in a couple of months. But when you do harvest, when you're doing fruits, vegetables, you've got a time crunch here. And that also makes it difficult if the coating supplier comes up with the absolutely best coating in October or November. You have to wait a whole nother year before you can pack it. So if a problem, again, as I said, you will delay the restart if you have a seasonal pack. So with a failure, reset the pack, and shelf life timelines again. You've got to do everything over. So to put this into a nice summary, you need to identify the alternatives. That can be rather straightforward. There are challenges to ensure the safety and compliance of the alternatives. You have to make sure there's NIAS, you have to do migration testing, you have to do tox testing. And then there are challenges to ensure that the alternatives perform the same along the shelf life and also for production. Substitution is a very long process. So thank you for your attention.